Hello everyone, today we're going to be going over the constellation Perseus. According to Greek mythology, Perseus was the only son of Zeus and Danae. Thus, he was only half god by birth. Perseus was one of the greatest heroes in Greek mythology. He was most renowned for beheading the only mortal Gorgon, Medusa. And if you see here it is Perseus, and he's using Medusa's head as a mighty weapon against his enemies. A fun fact that you should know about Perseus is that he's married to Andromeda. And as we have seen, with Constellation Andromeda, it's interesting, how all these Greek heroes, they're all somehow intertwined. So the shape in the sky. The stellar configuration is thought to resemble the Greek hero Perseus, and here you have him raising his diamond sword, while in the other hand he has the head of Medusa. Personally, I think that this looks like a backwards Y, but that is only up to the viewer's discretion. So how can we locate Perseus, and when is it best observable? We can locate Perseus by locating it in the northern sky next to Andromeda. If you see here, this is Perseus. You have Andromeda right over here. And you have Cassiopeia, which is right above Perseus. You could also locate it by finding Cassiopeia, which forms a W or an M. It really depends on the location where you're observing. The constellation Perseus can best be seen in the late summer and autumn in the northern hemisphere. It is visible at latitudes between 90 degrees and negative 35 degrees. Another thing that I forgot to mention is that we could also locate Perseus by finding its double cluster, since the double cluster is visible to the naked eye. And we're going to go over that in the next few slides. The Perseid meteor shower. The Perseid meteor shower is observable between July and August, as we learned in Chapter 9. Bits of dust and other debris from a comet nucleus tend to spread out along the orbit of the original comet nucleus. When Earth passes through the concentration of cometary debris, the result becomes a meteor shower. So every year, Earth passes through the path of the comet Swift-Tuttle from July 17 through August 24th, with the showers peak as Earth passes the densest and dustiest area, occurring between August 11th and the 12th. Unfortunately, due to light pollution, it's not very visible, but you could try a place maybe in high altitude or where there's just not a lot of light, so you could observe this beautiful scene. The most famous star in the Perseus constellation is Algol, also known as the demon star or head of the demon. Algol got its name from Medusa's head. If you remember, based on the shape of the constellation, you had Perseus on one hand holding his diamond sword, while in the other he was holding Medusa's head, or the head of the demon. Well, that head is supposed to represent Algol. Algol is a three-star system consisting of Beta Persei A1, A2, and AB, in which the hot luminous primary B Persei A1 and the larger but cooler and fainter B Persei A2 regularly pass in front of each other, causing these eclipses. And this is the reason why it blinks. So if you go outside, and if you locate Algol, you will see it constantly blinking. Also, remember, if a binary system is viewed nearly edge-on so that one star passes in front of the other, it's called an eclipsing binary, as we learned in Chapter 10. Also, if I'm correct, you can use the Newton's version of Kepler's law to find the mass of a star when two stars orbit around each other, also learned in Chapter 10. The demon star has a magnitude of 2.12. It's considered a blue-white main sequence star in the spectrum. Algol has a spectral type of V8V, a surface temperature of 12,000 Kelvin, and a luminosity 98 times the sun. It is also known for its paradox, which we'll look at in the next slide. Well, what is the algo paradox? You see, that's a good question. The algo paradox refers to the observation that the binary star system algo does not follow accepted models of stellar evolution. If you remember in the previous chapters, we learned that high mass stars have a shorter lifespan than low mass stars, and that was because they fuse through their hydrogen faster than low mass stars. Yet, the paradox in ALGO is that the low mass star, which is a subgiant K-cool star, is in the process of dying, but its companion, which is a higher mass B star, has a shorter lifespan, but it's not dying. And if you see here, this is the mass exchange, and which is why it's a paradox. But it's really the result of the mass exchange today. The giant lost 2.2 mass of the sun and shrunk into a subgiant star, which is kind of cool. But this is only possible because it is a binary star system, if I'm correct. But yeah, along with the Algol star, the Perseus constellation is also known for its double clusters, which are located right here. They're both visible to the naked eye, and also right here. If you see Cassiopeia is right here, the double clusters are right there. So the double clusters are circumpolar, which are visible all year long. It's in proximity again to the constellation Cassiopeia. It consists of two open clusters, NGC 869 and NGC 884. NGC 869 and NGC 884 lie at a distance of about 7,500 light years away in the Perseus arm of the Milky Way galaxy. They're both relatively young clusters, about 13 million years old. This is very young compared to other clusters like the Messier 45, whose lifetimes range from 75 million years to 150 million years old. It's important to note that each cluster contains about 300 blue-white supergiants, and their hottest stars on the main sequence belong to the spectral class B0. Both clusters contain a significant number of bright young O and B stars. Tip: we can use the color magnitude diagram to determine the age of the cluster by looking at the turnoff point and find the VV of one of those stars, as we learned in just the last section of the lab. I hope that you guys all liked my presentation on the Perseus constellation. Here are 3 quiz questions to test your knowledge. Have a great day.